Hello. Can you all hear me well?
Yes, ma'am.
Can you see the screen as well?
Yes.
Yes, ma'am. Yes,
Yeah.
it's visible.
Okay. Okay. So today we will be discussing module 2, that is testing throughout the software development lifecycle. So in this module, we'll be discussing about different STLC, how testing is happening in each of the STLC, etc. So first topic is testing in the context of software development lifecycle. So each company or organization will be following a different STLC, or based on the project choices, STLC would differ. So it is very important that we have a fair understanding about different models used. What are the different methodologies? How does it really vary from each other from a testing perspective, which is very important. So what does STLC define? It actually defines how different development phases and types of activities within this process relate to each other. So how each process relate to each other, that is the whole definition of SDLC. So what are the different phases in an SDLC? What are the different phases in an SDLC in general? In the different phases SDLC. What are the different phases in SDLC? So there'll be the requirements gathering phase, and there'll be the design phase, and there will be the implementation or development phase, and then finally we have the testing phase, right? So there are different SDLC models, and the testing happening in each would be different. So there are many factors which influence testing, and one of the main factors influencing testing is the type of SDLC we choose for that particular project. So as per ISTQB, they have given few SDLC model. So the first one is they have given sequential development model. So the waterfall model and V model together comes under the sequential development model. So what is sequential development? What happens in sequential development? So from the word itself, we know it happens in a sequence, right? So here what happens is in sequential development model, if we take the example of waterfall model, each development phase would be started only after the previous stage is completed. So we know that the first phase is requirement phase and the second phase is design phase. So as per the definition of waterfall model, it would start, one development phase would start only after the previous stage is completed and is accepted by all the stakeholders. So if design phase is to be started, that means the requirements phase is already completed and is agreed upon by all the stakeholders. That is that is how the waterfall model works. So if one phase is to be started, it will start only when the previous phase is completed and is approved by all the stakeholders. So what would be the drawback here? What would be the main drawback if you're following a waterfall model? What would be the main drawback?
Time
Effective
consuming.
fault.
Time consuming, that is a drawback.
Effective fault will be found at the end.
Sorry, I can't hear you. Can you be a little louder?
Defective bug will be found at the end of the.
Right, right. We have clearly defined that each phase will start only after the previous phase is completed. So what happens? The testing happens only towards the end. And so the defects will be found only towards the end. So all we are trying to find is we should be able to find the defects at the earliest. So, but in waterfall model, the testing happens only towards the end, and so the defects will be found only later in the life cycle. Right, that is one main disadvantage. The other one is no changes can be incorporated. Right, so we have clearly defined that in order for one phase to start, if design phase is to be started, that means the requirement phase is already frozen, right? So there is no way we can incorporate changes. If there is something need to be implemented, that would always come from the start. So in between, during the development phase, you can't make a change in the requirements, right? That doesn't happen. So incorporating changes is very difficult in waterfall model. That is again one disadvantage. Another is it is not a disadvantage in waterfall model. We can say that there will be no rollback. So you are in the design phase and you want to make some changes in the requirement. So you want to go back to the requirements phase. That will not happen. So there is no rollback. There is no layover phase also. So there can't be a stage where two phases overlap with each other. So you are in the requirements phase, it is not complete, and you just want to start with the design phase already. That will not happen. So there is no overlapping phase, there is no rollback. And the main disadvantages is the two main disadvantages is that the testing happens only towards the end and no changes can be incorporated. These are the few features of a waterfall model. So what happens in V model? V model is another sequential development model. And what happens in V model? So we, although V model and waterfall model are comes under the sequential development model, in V model, the testing principle is that we would be able to do the testing at the earliest, right? So V model applies the testing principle of early testing. So for every development phase, there is a corresponding testing phase. So when during the requirement gathering phase, a testing team will be involved in preparing the acceptance test cases, right? So there is a testing phase for every development phase. So we can say this is one of the ISTQB questions which has been asked earlier, like which is that one model which applies the testing principle of early testing. So that can, if depending upon the different options given, you can come to a correct answer. But if V model is given as an option, you can always pick that answer because V model applies the testing principle of early testing. So what could be an advantage in the sequential development model? What could be an advantage in the sequential development model? So main advantage is that the client will get a fully completed set of features. So, but it can be a disadvantage as well because since it takes a long time for delivery, it might take years or months and it might get obsolete by the time. So the advantage is that the client gets a full set of features. So that is a waterfall and V model. So the next model is iterative model. So what happens in iterative model? It would be mostly of time boxed iterations of 2 to 3 weeks. Again, the time can change based on the project scope and the expectation from the project. Basically, it will be time box iterations of 2 to 3 weeks. And the expectation is that each iteration will be delivering a working software, which will be growing until we get the final software delivered. So the whole project will be in different iterations of 2 or 3 weeks, and each iteration will deliver a working software. So here the intent is that we will be delivering the project in small iteration, which gives very early feedback in every iteration, and these iterations will continue till we deliver the final product. So here we can take the example to compare these two different models. We can take the example of building a house. So if we give a contract for building your house, and the sequential development model is more like you are coming to see your house only once the whole house is built and is available to you. So then the problem is if you want to make some changes in your house, that might not be possible at that later stage. But rather, if you were having a visit every 2 or 3 weeks or every 1 or 2 weeks, then you could suggest or you could give some feedback like these things needs to be changed. I don't want this in this place. So that could be changed. So sequential development model and the iterative development model is similar to that. Like in waterfall or the sequential development model, it is very difficult to make changes in between. Whereas in iterative model, since after every iteration, we are getting a feedback and so changes can be made. And the final one is incremental development model. So what is incremental development model? So one of the example is a rational unified process. So what happens here is the difference here is that the increments would be relatively for the rational unified process, that the increment would be relatively longer. And since you when we say longer increments, that means the features will also be complex features and would be large enough for that time. So what happens in an incremental model is that we will be dividing the whole application into smaller increments, and each increment will have the different STLC phases happening. For example, if the whole project we have divided into n increments, so the whole project means the sum of all these n increments. And for each increment, so say the first increment n1, we will have all the different STLC phases happening. There will be the requirement gathering phase, there will be the design phase, implementation phase, as well as a testing phase. So the definition here is the whole product will be divided into different increments, and each increment will have all the different STLC phases happening. And each of these increments, N1 and N2, till the n number of increments, whatever we have divided it into, the sum of it will be the whole final product. So these are the four different types of STLC model. So you should be able to like you should be clear about the concept. If someone asks where does testing happens in waterfall model, so you should be able to if the concept is here, you can clearly say that the testing happens only towards the end. Whereas in V model, testing happens for every development phase. In iterative model, each iteration will have a testing phase. Similarly for the incremental model. So you should be able to identify each testing perspective of each and every STLC model. And few other examples of the STLC models are ATT, BDD, DDD, Extreme Programming, FDD, Kanban, Lean. So we'll have a look into the different other STLC models later in this module. Yeah. So that was it for the context. And next is impact of SDLC on testing. So as we have just had an overview of where the testing actually happens in each SDLC. So now we will see in detail the impact of SDLC on the whole testing process. So the first one is scope and timing of test activities. So the scope and timing of test activities in each type of SDLC model will be different. So let's see what is it. So in sequential development model, so for waterfall model, the testing happens only towards, and that is what we have just learned. So here in sequential model, the testing happens only towards the end. So if we take the waterfall model, we know that each phase happens only after the previous phase is completed and is frozen. So in such traditional methods, testing happens only towards the end. So is used for such project which takes time for implementation. So depending upon the what kind of project we are taking, so we can choose what kind of SDLC model should be applied for that particular project. So in sequential model, it is more compatible for projects which takes time for implementation, because it takes a lot of time for each phase to start only when the previous phase is completed. Whereas in Agile, test activities happens throughout the development phase. So testing activities are integrated throughout the development cycle, with testing occurring continuously during each sprint. So it is not that in Agile, we will just wait for some activity to get over so that we can start testing the application. So that is not how it happens in Agile. The testing activities are integrated throughout the development cycle. So all the activities begin parallelly, and testers will start preparing or understanding the requirements and preparing the test cases. So we don't have to actually wait for the development phase to get completed so we could start the analyzing of the requirements or any other test process. So the testing activities are integrated throughout the development cycle in Agile. Next is level of detail of test documentation. So in any of the sequential model, we know that the documentation is very detailed. So we will have to prepare a comprehensive and very detailed test documentation, like extensive test plans, test cases, test scripts, which aligns with the predefined like requirements and design specifications. So for sequential model, we know that the all the requirements will be available upfront. So based on that, we will have to prepare an extensive test plan and test cases. Um, Whereas in Agile, the documentation is very brief. You know that we will be using the Agile artifacts like user stories and epics to like create the requirement. So the documentation is very brief in Agile. And the next is choice of test techniques and test approach. So in traditional development models like waterfall or V model, we use the traditional test techniques like the black box and white box test techniques. Whereas in Agile, um, the approaches which provide early feedback like TDD, BDD, test driven development, behavior driven development, all those modern approaches would be used for Agile. Whereas in sequential models, we will be mostly using the traditional techniques like black box and white box. Next point is extent of test automation. So in traditional models like waterfall or V model, there will be only limited automation because the focus would be mainly on manual testing as because of the sequential nature, because there'll be the we'll have to wait for each phase to get completed. So and finally we have the whole product completed with us, then we could do a whole manual testing. So there is no limit for testing in sequential development model. Whereas in Agile, what happens is we have an iteration of 2 or 3 weeks. So we are supposed to make sure that that particular feature or that particular epic or that particular set of user stories which we have picked for that particular iteration is tested properly before we actually close that sprint. So there is a limited time, and so we will have to depend more on the test automation. So after each sprint, the number of test cases might increase. So it is not possible that every time we can go and run all the test cases from the previous sprints manually. So in such cases, all the priority test cases from the previous sprints, we will be adding it up to the regression. So there is a lot of automation happening in Agile, whereas in sequential development model, the extent of test automation is very limited. And then finally, we have the role and responsibilities of a tester. So in sequential development model, from the definition itself, we know that the testing happens only towards the end, with very less involvement in early development stages. So whereas in Agile, it is cross-functional. We should be involved in different meetings, all the different meetings happening. We should be for example, if we say there is a release planning meeting or any other kind of meeting, for sequential development model, the participation from a testing team would be mostly limited to the team lead or QA lead or QA manager. But that is not the case in Agile. So all the testing team members are working in a cross-functional manner, and we should always be involved in all the different meetings associated in that particular piece of work. So that is those are the different impact of SDLC on testing. So we have the role and responsibilities of a tester, the extent of test automation happening in each SDLC, choice of test techniques and test approach, level of detail of test documentation, and finally the scope and timing of test activities. And next is SDLC and good testing practices. So before we start this SDLC and good testing practices, let me ask you one question. Is it possible we can do dynamic testing early in the sequential development model? Can we do dynamic testing early in the sequential development model? So if you got the concept of sequential development model, you would be able to answer it. can dynamic testing be done early in the sequential development model? You can put, yeah, answer here on the chat also. It is not possible, right? Because the executable code is usually created in the later phase, and only once that phase is complete, we'll start the next phase. So dynamic testing is not possible to do early in the sequential development model. And the next question, which development model perform both static as well as dynamic testing at all different test levels? Static and dynamic testing can be performed at all different test levels. For which development models? Iterative, that's correct. Any other options? So we can V model. How is it V model? So V model also we are doing evaluation for every development phase. So that is also correct. Is there any other model? From what we have learned, there are so many different other models. From whatever we have learned, V model is right. For each development a phase, we are doing our testing. And V model is that one model which applies the testing principle of early testing. And iterative is correct because for each iteration, we are supposed to run all the different SDLC phases, right? So each iteration will have a testing phase, and so we'll have both static testing as well as a dynamic testing. And the same thing happens in the incremental model also. So except for waterfall model, correct. Or except for waterfall model, we can say that all the different models, the static and dynamic testing can be performed. Okay. So next is SDLC and good testing practices. So these topics, no, where you might feel it is not very important or significant, but from an exam point of view, the questions have been asked from this topic many times. Okay, so SDLC and good testing practice. Is there any good testing practices which you follow in your organization? Like, are you given any set of practices which is to be followed in your organization? Like you have to write these many test cases, or you have to maintain an RTM or anything like that. No. So ISTQB is like giving few practices, not necessarily some steps or anything, but few practices that could help us in achieving a better quality product. So first one is, for every development activity, there is a corresponding testing activity, so that all the development activities are subject to quality control. So we have to, it is not just the final developed code that is to be quality control, that is to be subject to quality control. Rather, the whole process, all the development activities are should be subject to quality control. So we can take the example of a V model here. So for V model, we know that for every development activity, there is a corresponding testing activity, right? So, so these principles are not specific to any one SDLC model. For example, if you are given a question like, for every development activity, there is a corresponding testing activity, for to which SDLC model this applies. So if someone asks, if the question is asked that way, we might feel like the answer is V model, but the answer is not V model. ISTQB is saying, irrespective of any models, whatever we follow, these are the good testing practices to be followed. So for example, if you are working on a banking application, and we know that banking application will have lots of formulas and logics happening. So say there is a error in the formula to calculate the interest. So if we were reviewing the requirements properly, what would have happened? We could have identified the issue earlier in the life cycle during the requirement phase or something. But if we haven't like looked into the requirements properly, haven't reviewed the requirements properly, what will happen? The issue will get propagated to the next phase, that is a design phase, and then from there to the implementation. And finally, after coding only, we will be getting to know that okay, there is an issue. So if for every development activity there should be a corresponding testing activity, so we can make sure that all the different development activities are subjected to quality control. Next point is each test level has test objectives specific to that level. So we have 5 different levels of testing, or 5 different test levels, which we will learn later in this module. So different levels of testing are like component testing, integration testing, component integration testing, system integration testing, and acceptance testing. So the point here is each test level has a test objective specific to that level. So the objective of component testing is to find out the issues in the component or unit, whereas the objective of acceptance testing is to verify if the final product, whatever we are getting, is acceptable or not, or if it is abiding by the acceptance criteria or not. So the objective of each level should be specific to that particular level. We have to make sure that there is no redundancy. So this the objective should be specific to each and every test level. And the next one is test analysis and design for a given test level begin during the corresponding development activity. Again, we can take the example of V model. During the development activity itself, testing team will be conducting the corresponding testing activity. So during the system design, when the developers would be working on the system design, the testers would be working on designing the corresponding test. So test analysis and design for a given level should begin during the corresponding development activity. We should not be waiting for the development activity to complete, or only after the development activities the test analysis and design should happen. It should happen during the corresponding development activity itself. Finally, testers are involved in reviewing work products as soon as the drafts of this documentation are available, so that this earlier testing and defect detection can support the shift left strategy. So the shift left strategy is that we are trying to take testing towards the left. So from a general STLC timeline, we know that testing only happens towards the right. First, the requirement analysis happens, then the design, then the implementation, and finally the testing phase. So we are trying to take testing from the right to the left. So the bugs or issues could be identified earlier. So here the key point is as soon as it drafts. So what do you mean by the draft? What is a draft? When you say I'm drafting a mail, is it something which is complete? No, right? So draft is something which is a first version, which is not actually the completed final version. So here the point is that testers should be involved in reviewing the work products, whatever work product it is, they should be involved as soon as the first draft is available. They should not be even waiting for the final completed document to be part of the discussion and meetings. So it should happen, the reviewing should happen as soon as the draft is available to them. That is a key point. So we could support the shift left strategy. So these are the different good testing practices that is to be followed irrespective of the SDLC models that we take up for our project. Okay. So the next is testing as a driver for software development. So here the statement itself says testing as a driver. Testing should be driving the whole software development process. So here we will be talking about few agile techniques where testing will be acting as a driver, or testing will be defining the directions on how the development should be carried out. So since testing is a driver, all of these approaches follows early testing, and hence there is a shift left approach. So shift left approach is a term which is very prominent now. So where we are trying to take the testing prepone the testing from right side to the left side so that early testing can be carried out and issues could be identified in a early development state. So testing as a driver means testing will be driving the whole development process. And since all of these approaches follows early testing, it aids in shift left approach. So the first one is test driven development. So what happens in driven development? So all of these approaches, tests are defined before the code is actually written. So shifting something to the left hand side of the life cycle, which was already happening towards the right of the life cycle. So here the automation scripts are developed first, which is right opposite to that of the general life cycle. So what happens in the general life cycle? So unit tests are written prior to the unit code. So what happens in general life cycle? The unit codes will be written and later on the unit tests will be written. Whereas in test-driven development, some just opposite of to that general life cycle happens. So here the unit tests will be written first and then the unit codes will be written. So TDD is an approach where the unit test cases are written prior to the unit code. So we know that test is that one thing which finally validates the code, right? Test is the one thing which finally validates the code. Then why do we have to actually write the, why don't we write the test first rather than all the design and things and waste a lot of time? So we write the test script first and then give it to the developers and ask them to go in repeated loop to make correction until the test pass. So the step here is first write the unit test and then give it to the developers. Then the developers will write a unit code to make the test pass. So if in the first case the test is not passed, then they will make more changes to their code until they succeed, until the test actually passes. So that is how it will work. The actual code will be validated by a set of unit test cases, which is actually written first. And if the test passes, that means the code is appropriate and it is meeting all the requirements. And if in case the test fails, that means the code has some anomaly with the required requirements. And then the developer needs to fix it till it meets the requirements. So sometimes they might have to go multiple times changing the code to make it finally pass. So here in general, we can say that in test-driven development, it is just opposite to that of general life cycle, where unit tests are written prior to the unit code. So this is mostly a technically written, right? So that's why it is only applicable to the unit level. So then next is acceptance test-driven development. So we have already said test-driven development, it is technically written, that unit tests are written prior to the unit codes. So whereas in acceptance test-driven development, what happens? The difference here is that tests are not technically written. Rather it is derived from the acceptance criteria. So in Agile, we know that once if we are given a story for testing, what happens? Finally, we have to make sure that all the acceptance criteria mentioned in that story should be like tested. We have to make sure that all those acceptance criteria are satisfied. Then only we can change the story to done status, right? So it makes a lot of sense when we write test from the acceptance criteria. So the first one was technically written, whereas the acceptance test-driven development, here we derive tests from the acceptance criteria, focusing on ensuring that the system meets those requirements mentioned in the acceptance criteria. So here also the test is written before the corresponding part of the application is developed to satisfy those tests. Finally, we have the are you aware of the tool Cucumber? Cucumber is one popular open source that allows developers and testers to write acceptance tests in a natural language format. So finally, we have the behavior-driven development. So first we discuss the technically written, that is a test-driven development, and then we have first the technical phasing, and the second is business phasing, and the third is requirement phasing. So we have a language called jerking, which is in the given when then format. So given certain expectations or prerequisites, when a user perform these actions, then this is what should happen, expect to happen. So what happens is we can translate this given when then format into programmable executable test scripts, and then the development will happen on top of it. So one main advantage of the BDD is that it encourages collaboration between developers, testers, business stakeholders by using a common language just to describe the system behavior. For example, if in BDD, the different stakeholders and team members collaboratively define some scenarios. They define a particular feature, say login. So they define it using the given when then format, and describe the expected behavior of that particular feature. These scenarios serve as the executable specification that would actually drive or guide the development and other processes. So there are some tools which actually support the BDD as well. So these are the few approaches which is being widely used now, which will actually, what happens here is testing is acting as a driver for the whole software development process. And next we have DevOps and testing. So what is DevOps and testing? What is DevOps? What is DevOps? So DevOps as a word, what does it mean? Development and operation, right? So when you say development, it includes the coding and implementation phase, and operations means when it is live or when it gets into its environment. It is whatever the target environment is, whether it is production or UAT. So we are not talking about testing here, right? So are we actually eliminating the testing phase in DevOps? So are we actually eliminating the testing in DevOps? No. So DevOps, the dev part includes an embedded testing phase. So testing is not happening as a separate dedicated phase, whereas testing will be happening embedded in the development phase. So why DevOps? DevOps tries to create a synergy between the development as well as the operations phase. So what actually happens in DevOps? So how the DevOps activity happens is like, so every single check-in should trigger a build verification test as well as a regression test. So what happens is, so every time a developer writes a code and checks into the repository, the common source code repository, what happens is every single check-in into the repository will trigger a build verification and many other activities. It is not limited to just build verification, because when a developer is checking in a new code, that is a change, and we are supposed to make sure that that particular code change is not affecting the functionality, or there is no bugs in that particular code change, right? So whenever there is a code change that is being pushed into the common repository, a build verification test as well as many other automated activities would be triggered to make sure that the new unit is working fine. And at the same time, this unit integrated with the existing piece of code, it is not breaking all the existing functionality. That is, there is no regression happening. So this continuous integration and testing can be achieved using the DevOps. So there is continuous changes happening. If there are different developers, they will all be creating new piece of code. Those will be pushed into the common source repository, and any change any time would trigger mm, all these different build verification and as well as other different activities, automated activities, and this will help us in getting an early feedback. So if there is a new code that is being pushed into the repository, the automated build verification or the automated regression test will run, and we will get an instant feedback that there are some issues in the code, or if it is passed, that or the all the automated regression test and build verification test are passed, that means the code is okay. So this can be the early feedback, and early integration and continuous delivery can be achieved using DevOps. So there are few benefits of DevOps. We will see what are those. The first one is fast feedback on the code quality and whether changes adversely affect existing code. That is one thing which we mentioned. So whenever there is a change, it is our duty to make sure that the particular piece of code, particular change in the code, change of new code that is being pushed is not affecting the existing functionalities, as well as there is no bugs in the that particular piece of code. So what happens in DevOps, this will trigger the automated test scripts, and it will give us a fast feedback. So DevOps provides fast feedback on the code quality by enabling this continuous integration and automated testing. So what happens, developers will receive an immediate notification if changes adversely affect existing code, or if there is any critical issues, or allowing, which will actually allow them to make changes fast. So that is one important advantage or benefit of DevOps, that is, it gives fast feedback. And next is shift left testing with continuous integration. So CI promotes a shift left approach in testing by encouraging developers to submit high quality code accompanied by component test and static analysis. So there is a shift left approach. So we have been talking about the shift left approach. What is shift left approach? We are trying to do testing in the earlier phases of development, so that we can get an earlier feedback and the issues can be fixed earlier in the development phase. So CI actually promotes, CI means continuous integration. This continuous integration is enabled by the DevOps process. So CI actually promotes a shift left approach in testing by encouraging developers to submit high quality code. Definitely. So as DevOps is implemented, and for every change, they will get a feedback like these many issues are there. So definitely, it will encourage developers to make sure that before they actually submit the code, they will make sure that their code is of high quality, and corresponding component test and static analysis is done. So what is the advantage? This will ensure that defects are identified and addressed earlier in the development process. So which is very important, because if we do not find it earlier, it will be very expensive and difficult to fix the issues later in the life cycle. So for example, if we take, developers use CI tools like Jenkins, which can actually automate the build and test process. So as part of continuous integration, unit test, integration test, static code analysis, all these activities will be run automatically whenever the code changes are made. So this will help the developers to catch and fix issues at the earliest. So, and next is promotes automated process like CI/CD that facilitate establishing stable test environment. So it is not about testing the new code changes. It will also enable or promotes facilitating stable test environment. So DevOps promoted automated process like continuous integration or continuous delivery that facilitate the establishment of stable test environments. For example, there are some tools like Terraform or Ansible, which automate the provisioning of test environment. So automatically, this will automatically deploy the changes to these environments, ensuring that testing can be performed in a consistent and reproducible environment. That which is very important from a testing perspective. There should be a stable test environment. So these are few benefits. Few other benefits are increase a view on non-functional quality characteristics like performance and reliability. So what is performance testing? What is performance testing? What is performance testing? Like we are actually checking how the system or how the application performs, right? So for example, if 1,000 users are using the application at the same time, how the system is responding, or for every request, how fast you are getting a response. So whatever actions a user do on the web UI, those are sending request, and we will be getting a response back. So how fast we are getting the response back. So when you're clicking on a button in an application, you are expecting an immediate response, right? Or is it like you are clicking on the login button, you have given the credentials, and then you click on the login button. Mm, is it like you expect the application to take 5 minutes to log in? No, right? From a user perspective, we will always be expecting, as soon as you click on the login button, you will be expecting to get logged into your account. So there are a lot of non-functional characteristic that is to be mm, done. So in a general testing perspective, all these different non-functional quality characteristics would be done, or the testing would be done mostly towards the end, once the whole application is available, right? So but because of the DevOps, what happens is the unit level performance testing, or unit level reliability testing, or other different non-functional quality characteristic testing could be implemented in the DevOps pipeline. So whenever a developer is pushing a new code, um, the static analysis and the corresponding performance of that particular unit code, or corresponding any other non-functional characteristics of that particular unit code could be tested then and there itself. So there is an increased view on the non-functional quality characteristics, most in general, which would have happened only once the whole application was developed. Normally that's how it happens, whereas with DevOps it could be done for every unit code or every new change that is being pushed into the repository. So this increases the view on the non-functional quality characteristic. So another one is automation through a delivery pipeline reduces the need for repetitive manual testing. So definitely with different regression suits that is being done on a delivery pipeline. So there is no need that whenever there is a new code change, say you are in sprint 5 and you have 150 test cases from the all the previous 4 sprints, it is not possible that we can go and test all these different test cases from the previous sprints manually. That is not possible. So with automation, with mm, um, implementing automated scripts on the delivery pipeline, the need for repetitive manual testing is reduced a lot. So automation through the delivery pipeline reduces the need for repetitive manual testing. And finally, the risk in regression is minimized due to scale and range of automated regression suite. Because of the automated regression use test, what happens is there is less risk in regression. So even if there is any regression created, that could be identified at the earliest whenever the code is just pushed before it is actually getting deployed, or before it is actually getting moved to the next stage. It could be identified as soon as the um, code is being pushed, and the corresponding authorized persons or developers will get a feedback that there is an issue and it needs to be fixed. So the risk in regression is minimized due to the range of automated regression tests. So these are different benefits of the DevOps, which is very important. Again, DevOps is one topic where questions have been asked, like for the two previous exams from the syllabus, the questions have been asked from the DevOps topic as well. Next is risk in DevOps. So it is not just benefits. There are risks also. So the first one is DevOps delivery pipeline must be defined and established. So there should be some resource who is well versed in this particular DevOps process, who could define a proper delivery pipeline, and that can be established. So that is, if the your organization don't have such a resource or facilities, it will be very difficult. That is, or if you try to implement DevOps, at this could be a risk. And next is CI/CD tools must be introduced and maintained. So that is something new, which we will have to be introduced into our organization, and it is to be maintained properly. So if we don't have the proper resources or proper facility for that, that could also end up as a risk for our project. And finally, test automation requires additional resources and may be difficult to establish and maintain. So, if we have to implement the DevOps in test automation scripts in DevOps, there should be resources who are good in writing the test automation scripts. So, these are different risks which are associated with the DevOps. Yeah, so there is DevOps, its benefits as well as the different risks associated with DevOps. Next is shift left approach. So whatever terms we have been discussing till now, those are all different approaches which helps us in shifting the testing process towards the left. So what is shift left approach? We are trying to take testing to the left, which gives early feedback, which means testing is happening in the early stages of development. So something, this is becoming very popular nowadays, like something which is happening later in the life cycle is being now happening earlier. So let's see few ways which we can implement shift left approach. So the first one is reviewing specifications from the perspective of testing. So we have taken an example before of the banking application. So we should be reviewing the documents or the requirements or whatever like test bases we have. We should be reviewing those from a perspective of testing, so that we can identify if there is any ambiguities or if there is any issues or if there is any gaps. So that is very important. So to review the document and to review the document from a perspective of testing, which will involve analyzing the requirements or user story to identify any potential defects, is very important, which helps in shift left approach. And next is writing test cases before the code is written and have the code run in a test harness during code implementation. So that is something which we have been discussing. We, in the actual general process, how it happens is the test cases would be written. The unit test cases would be written only after the code is written. Whereas in shift left approach with a TDD, test driven development, or acceptance test driven development, or BDD, all these what they are trying to do here, the test cases will be unit test cases will be written before the corresponding code. For example, in test driven development, developers write the unit test before writing the corresponding code. So these tests define the desired behavior of the system and guide the whole implementation process. So what happens? This will result in the code that actually meets the specified requirements. Next way to implement shift left approach is using CI/CD. So one main advantage of CI/CD is that it comes with fast feedback. So whenever there is a change in code that is being pushed to the common repository, what happens if there is the automated regression test or all the different activities that is being kept in the delivery pipeline, those will be automated. And if there is any issues in the new code that is being pushed, it will be intimated to the corresponding or authorized person. So they will they'll get a feedback at the earliest, and so they can make changes at the earliest. So with CI/CD, there is a we can actually implement the shift left approach, that is testing at the earliest. And next is completing static analysis of source code prior to dynamic testing or as part of an automated process. So we also implement, it is not just the automated scripts that we keep in the DevOps process or the CI/CD pipeline. There are so many different activities that gets triggered when a new code is being pushed. So one of which is the static analysis of the source code. So once when a new piece of code is being pushed to the source code, what happens is this static analysis tool will scan this new piece of code to check for any vulnerabilities or any security issues or any errors. So all those static analysis of the source code would be done before we actually execute the actual code. So there is a static analysis of the source code happening, which again helps in early detection of issues. So that is also a shift left approach. So by implementing a static analysis of the source code, we can promote shift left approach. And finally, performing non-functional testing, starting at the component test level wherever possible. So wherever possible is very important. It is not possible that for all the non-functional testing can be done for every unit code. That is not possible. For example, if you want to do a some compatibility testing or a usability testing. So if you want to test how easy it is to use a particular application, you would actually need the whole application to actually test that, right? So it is wherever possible, we try to make sure that the non-functional testing can also be done from a component test level. But all the non-functional testing might not be possible to be done on a component test level. But for example, the performance testing. So performance testing is something which can be done from a unit component test level as well. So wherever possible, we will try to make sure that non-functional testing is starting from the component test level as well. So these are few different approaches which actually promotes the shift left approach. So if there are a lot of ways by which shift left approach is being maintained in our project, we can make sure that there are less number of issues once the application is being developed. Yeah. And the next topic is retrospective and process improvement. So this is one of the new topics which is being added in this news levels. So what is retrospective? So there are different names by which teams call this, different teams call retrospective. So some call it as post project meetings or project retrospectives. So there are different names. In general, it is retrospective. So when it is carried out, when actually a retrospective would be carried out. So it could be if by definition or from an agile perspective, it would be at the end of an iteration or a release. Or if not from an agile perspective, whenever a work is done, we try to review that work to understand what went wrong, what was the good things happened, what was the bad things happened, how we can improve. All those things will be discussed after a piece of work is done. So retrospective meetings are carried out at the end of an iteration or a release, or we can also say that at the end of a particular work to identify how the work has actually been done in that particular piece of work or in that particular iteration. So what is discussed? Success, failures, and opportunities for improvement. So what was successful and should be retained. So participants identify successful practices which were followed, the processes which were good actually, the outcomes from the project or iteration that contributed to the success. All these things would be discuss. For example, if we say a testing team recognizes that like implementing the automated regression testing has significantly reduced the number of defects in the latest release. So that is one thing testing team has recognized, and they put it as a successful thing. So and they decide to continue practicing this in the future projects. That is one. So what we do is we discuss about all the different successful things which has happened during that particular iteration, and those will be retained. So it is not just the testing team, all the members who were involved in that particular iteration for the particular in user stories in that particular sprint, all those team members will be part of the retrospective meeting, and they will put in all the different success factors and those that could be retained for the future sprints as well. So that is the first point. The next one is what was not successful and could be improved. So it is not just about we will be discussing just about the success factors or what went successful. We will also discuss and try to identify the areas where processes or practices fell short of expectations, and we will be discussing about how we can actually improve that particular area. For example, if in a retrospective, the team identifies that the communication breakdowns between the development and testing team, which actually led to delay in resolving defect, because there was a communication defect between the testing and development team. The bugs were resolved, like it took a time delay to actually resolve the defect. So they discuss strategies for improving the communication channels and collaboration, so that could be improved in the next sprint or in next iteration. So similarly, the next one is how to incorporate the improvements and retain the success in the future. So we will be discussing about the things which is to be retained in the first point. Again, we will be discussing about the failures and how we could be improved. So in the final thing that will be discussed is all those things which we have mentioned in the first 2 points, how to incorporate these improvements and retain the success in the future. So some people will be like asked to follow up on some activities that could be done. Some if the proper communication is there in between testers and development team, so how we can actually implement it by using a common channel for a particular feature or something like that. So how we can actually incorporate the improvements or retain the success, that is being discussed also. So based on the feedback from the retrospective, maybe in order to improve the communication, they might implement daily stand-up meetings. So the communication can be improved, and one of the team member will be responsible for actually conducting the daily stand-up. So all these are the different points that will be discussed in the retrospective meeting. So in short, we can say we are trying to improve the whole process, whatever has happened. So in the last iteration, whatever process has happened, we are trying to go a step ahead from the last sprint. So we are trying to improve the process from the last sprint. So next is benefits of retrospective in testing. So the first one is increased test effectiveness or efficiency. For example, by implementing suggestions for process improvement. So there will be different suggestions for improving the whole process. So which can actually lead to more efficient and effective testing practices. For example, after retrospective, the team implements a new test automation framework, which was suggested by the testers, which actually result in faster test execution and improved test coverage. So after having a discussion in a retrospective, we think of all the possible improvements and we actually implement it, which will actually help us in increasing the test effectiveness and efficiency. Again, this will also increase the quality of the test where. So example, by jointly reviewing the test processes. So there will be different test process. By jointly reviewing these test process in retrospective can lead to improvement in the quality of the test artifacts and test documentation. For example, the team identified that gaps in test case documentation. For example, if there are three QAs and three QAs are writing the test cases in three different format or three different template. So there should be a common template, or there should be an agreed standard in which all the different test documents should be written. So if there is a gap in any of the documents, that could be discussed, and this review process will improve the quality and consistency of the different test documentations. That is very important. And the next one is team bonding and learning. So, as a result of the opportunity to raise issues and propose improvement points. So, when you say, when we discuss things in retrospective, it is not that we will personally like target any one person who was not working well or anything. It is a collaborative work. So, through open and honest discussions in retrospective, team members share their insights, experiences, and best practices. Sometimes, if there is a senior person who was working in a different company, he would like to implement the good practices which he was following in his previous company. So there will be a lot of discussions. There will be a lot of bonding and learning from each other. Each one will share their insights, experience, and best practices. This will actually foster like a culture of collaboration and continuous learning within the team. So there is a lot of team bonding and learning. And the next one is improved quality of the test basis. So what is test basis? Test basis. You might have actually learned this in the first module. Test basis. Test basis. So based on what you are preparing the test documents or test cases. So it is a source of information. So if you want to prepare the test cases, you need some source of information. So it can be a requirements document or a design document, or maybe just a flow diagram. It can be anything. So test basis, the retrospectives can actually help us in improving the quality of the test basis. So if there is a deficiency in the requirements or test basis which was identified in the retrospective, which can actually improve the overall quality of testing effort. So the team can work with all the stakeholders involved to clarify the ambiguities and inconsistencies in the requirements, which is actually possible, resulting in a more accurate and comprehensive test basis for future testing activities. So, which is actually possible in a retrospective meeting, we can actually come up with such uh, suggestions and improvements. So, there can be more meetings with the corresponding stakeholders to actually clarify on the test basis or the ambiguities in the test basis, which will actually result in a more accurate and comprehensive test basis. And finally, the better cooperation between development and testing. So regularly reviewing and optimizing the collaboration between the development and testing team in retrospectives can improve the cooperation and alignment. For example, they come together as a team, and the development and testing team, they come together as a team and they discuss all the challenges they faced in collaboration, or any other work that is being included, or agree on any communication channel. So we will use this particular channel for this piece of work, or for this developers will keep this channel for their communication. So by better implementation of different communication channels, there is a better cooperation between the development and testing team, which will actually help in the whole testing process. So these are the different benefits of retrospective meeting. So yes, And so these are the different topics in module 2. The next one we will start with test level. So in the good testing practices module section, we have discussed that each test level has a test objective specific to that level. So we have few different test levels. The first one is component testing. The next is component integration testing. Next is system testing. And finally, we have system integration testing and then acceptance testing. So what is test level? What exactly mean by test level? So here a group of activities that are organized for a common test objective. As we have discussed in the good testing practices, each test level have its own specific test objective. Test objective of component testing might not be the test objective of, is not the test objective of component integration testing. It is different. So testing will be different in different test levels and different tasks will be performed in different test levels. So let's see what is each test level. So the first one is component or unit testing. So what is component or unit testing? So if we take any example, not just a software, if we take example of any product that is available in front of you, say for example, if you take a car. So when you do a final test drive on the car, that means you are actually doing an acceptance testing. You're actually what? You're actually driving the car to make sure if it is acceptable or not, if it actually fits for your purpose or not, right? So before we actually do the final acceptance testing, there are a lot of different testing that might have done on that particular car before we actually get it as the final car, right? So each and every part of that car is being tested individually. When you say each and every part, each and every single part, like the gear or the screws or the tire, each, it is not that any screw can be fitted into the car, right? So each and every part will be tested individually before it is being integrated to the next part, right? So the same thing happen in software as well. So each and every component or unit will be individually tested. So when you say each and every component or unit, what is component or unit in software? What is component or unit in software? It will be some piece of code, right? So component or unit is the smallest testable part of the system. And for a software system, it is the smallest testable code. It can be a method or a class or an object or a program or whatever it is. So the smallest testable part of that system, that is a component. It is done to verify that the lowest independent entity in a software program is working fine or not. So for example, the developers, they write the code for login. Then he does a testing on the code component, that particular piece of code, to see if it is working. That is a unit testing of that particular piece of code. So each and every testable unit or code is being tested individually. That is called the component or unit testing. So who will be doing it? Developers will be doing the unit testing in their environment. And they might take the support of test harness or unit frame. So sometimes what happens is unit testing, as we have discussed, is the first stage of testing. So when you want to do the unit testing of a particular unit, you might need the response from a different unit. For example, we know that this when you click on the country drop down, any drop down in a particular website, what happens? When you click on a country drop down, there will be a state drop down. Depending on what is your selection on the country drop down, the corresponding selection will be made on this, can be made on the state drop down, right? If you're selecting India from the country drop down, the states of India will be displayed on the state drop down. So these are two different components. If there is a some kind of testing where one unit's testing can be done only with a different unit, then for example, if unit A is to be tested and you need some kind of response or integration from unit B to do the complete testing of unit A, then in such cases, if unit B is not yet developed, so you want to do the testing of unit A, but you need some response from unit B, but unit B is not yet developed. In such cases, we might use the unit framework or test harness to actually simulate the response that is supposed to come from the unit B. So that is a unit framework. So for that, we use the stubs and drivers. So if when you do the component testing, if the main function is missing and you are using a dummy module, we call it as a driver. The driver function is missing and a dummy module is used for the driver, then we call it as a driver. And if a lower function is missing and we are using a dummy module for that, it is called a stub. So since component testing is one of the initial levels of testing, all parts or all modules might not be developed at that stage. And in such cases, if we need support for one unit testing, we might go for unit framework or stubs or drivers to complete the unit testing. So that is component of unit testing. So do we need to write test cases for unit testing? So there is no mandate that we should be writing test cases, but we can see that in actual projects that developers develop the JUnit test cases, it is always a good to have the test cases. And next is component index. So a few other names for component or unit testing is that module testing, white box testing, etc. So why white box testing? Because when you look into white box, you can actually see what is happening inside, right? So it is when you say white box, you can actually see what is a structure, what is a code, what is the logic, what is being tested. That is a component is being tested. So we call it as a white box testing. So these are the main points for the component of unit testing. So next is component integration testing or unit integration testing. So we have discussed component testing, and now say unit A or component A is being tested, and there is another component B. We have component A and component B. Those are individually tested for their functionalities during their corresponding component testing phase. Now what we do is we integrate these two components together and do the check on the interactions and interfaces between these components. So here, when you do component integration testing, we are not actually worried what is the individual functionality of component A or what is the individual functionality of component B. All we are checking is once these two different components are integrated, how the interaction or the interface between these two components are correct or not. That is a validation that is being done in component integration testing. So for that, we use different approaches like the bottom up, top down, and big bang approach. So this is an integration testing phase. So these words are very important in an integration testing. The interaction, the interface. We are actually checking the interaction or the interface or the communication between the different components. So one of the approach is a big bang approach. So what we are doing, we are integrating different components and then checking if the interactions or integrations are working fine or not. So as per big bang, all the different components are available at once. And then we are integrating all these components simultaneously, and then we do a testing. That is called the component integration testing using the Big Bang approach. So what happens in Big Bang approach? We are assuming that all the components are available at once, and we are integrating all these components simultaneously and then doing a unit integration testing or component integration testing. So one of the advantage here is that we would not need a stubs or drivers or unit framework, because like from the definition itself, Big Bang is saying that all the components are available. So we do not have to depend on a stub or driver. And the disadvantage is that since all these different components are integrated at once, it is very difficult to actually identify if there is an issue. It is very difficult to actually identify in which module or in which unit or which component the issue is actually happening, because it is all integrated at once. So that is one disadvantage of Big Bang approach. So Big Bang approach says that all these different components are available at once and it is integrated simultaneously. So the advantage is that you did not have to need the support of a stub or driver. And the disadvantage is that it is very difficult to track down or trace the root cause of the issues or where the issue is actually happening. And so that is a Big Bang approach, and that is a opposite of the bottom up or top down approach. So what happens in bottom up or top down approach? If we take top down approach, each and every component will be integrated one by one. In Big Bang, we integrated all at once, whereas in top down approach, each and every component will be integrated one by one. So the top component will be integrated to the next component, and then we will do an integration testing on that. We will make sure that there are no issues. If there are issues, we will not move forward integrating with the next unit. Rather, we will fix those issues. We will make sure that there are no issues between these two units. Then only we will move to the next integration. So that is how the top down or bottom up approach happens. So in top down, it happens from the top, whereas in bottom up approach, it happens from the bottom. So here, each and every unit will be integrated. Then a testing will be done. If there are any issues, those will be fixed, and then only we will move to the next integration. So here, the advantages of the Big Bang approach will become the disadvantages here, as well as the disadvantage of the Big Bang approach will become an advantage here, because if there is an issue, so it is very easy for us to actually track down where the issue is, because only two units are integrated. It is very easy to identify. Whereas the disadvantage is that we might need the support of stubs or drivers. If any unit is not developed yet and we need that support, we might have to look for the stubs or drivers. So you can take the same example here, like the country and state dropdown. So once these two different components are integrated, once you click on any of a particular country, the corresponding state should be displayed on the state dropdown. So these are two different components in the same system. These two different components are integrated, and we are checking the integration or the interface between these two components are working fine. Next is system testing. So now first we have done component testing, then we have done component integration testing, and now we have system testing. So here the we will be focusing on the overall behavior and capabilities of the entire system or product. So we will be treating the system as a whole, and we will be doing the testing. A functional testing or of all the different end-to-end tasks, and the non-functional testing of quality characteristics would be done. So if you take the example of an e-commerce application, so what we are doing is we will do an end-to-end testing of the whole application, a system or the whole system. We will consider the whole system, and a proper functional and non-functional testing will be conducted. So for some non-functional quality characteristic, it is preferable. We have discussed this point before. It is preferable to test them on a complete system in a representative test environment. So in some, for example, the usability, it is one kind of non-functional testing which cannot be done earlier. So it can be done only in a production-like environment where we will be able to check the usability of the system, whereas performance testing could be done on a component or system level as well. So In system testing, we will be considering the system as a whole and we will be checking against the functional and non-functional requirements. So that is system testing. And then we have system integration testing. For example, if we take the e-commerce application or any other application which is integrated to a different system, like if you are in the payments page of an e-commerce application like Amazon, you know that Amazon is a different system and you are doing the payments using your bank details. So these details will be sent to the banking server, which is a totally different application, different system. So system integration testing, if you want to do the proper testing of the payments page, you should get a proper response from the banking system. So there is an integration between the your system, the Amazon's application, and then a different system, that is a banking system. So system integration testing is when you focus on testing the interfaces of the system under test and other systems and external services. When you integrate two different systems and you are checking the integration or interface or communication between these two different systems, that is system integration testing. So when you do system integration testing, it is important that you have a proper environment. It is the proper stable environment or a proper production like environment is very important when you do a proper system integration testing. That is the system integration testing. And finally, we have the acceptance testing. As we have discussed before, we are actually checking if the product actually could be accepted or not, if it actually fulfills the requirements or not. So we are validating on the readiness of the deployment, if it can actually be deployed or not. So that is the acceptance testing. It is the final level of testing where we will actually check if the product can be accepted or not. So this could be mostly done by the client side. So there are different forms of acceptance testing: the user acceptance testing, operational acceptance testing, contractual acceptance testing, regulatory acceptance testing, and finally alpha and beta testing. So these are the different forms of acceptance testing. So acceptance testing is done to increase the confidence in the system. To it is almost like the system testing, but the focus is more on the behavior and capabilities of the whole system and product. So it will be mostly done by the customers or end users to confirm if the product is acceptable or not. So what is each and we'll just go through each and every form of acceptance testing. The first one is user acceptance testing. So here the client does the testing to check if the system can do what is expected from it. If A is expected from it and it is giving B, that is not right. So they will do a check to see what is the requirement and what is expected from it, so as to establish a confidence in the system to increase the readiness for deployment. So the business users or stakeholders who would be using the system would be involved in the user acceptance testing. And next is operational acceptance testing. So there would be some operational acceptance criteria. Like the operational acceptance testing is that testing where it will validate if the system meets those operational requirements. For example, testing the backup or restore. So if the system cannot do a proper backup or restore, that is a critical issue. For example, if you are testing a banking application and if the banking application is not able to do a proper backup or restore, that is a very critical issue. So as a customer, it is not that I do a transaction now and later on I don't need to look back into it. So there is importance for the historical data. There should be a proper backup. So if the system cannot do a proper backup or restore, that is very critical. So operational acceptance testing is where we actually validate such operational requirements. Other one example is disaster recovery or high availability. Say there is a huge offer going on in a particular application or a particular e-commerce website. There will be a lot of traffic, right? So if one of the server crashes, there should be a proper disaster recovery, or there should be another stand-up server, so standby server. So otherwise, that will be a huge loss for the company. So all these different operational criterias, that operational acceptance criterias like the backup or restore or high availability or disaster recovery, all these are tested in the operational acceptance testing. And next is contractual testing. So what is contractual acceptance testing? So for any product, a contract would be signed between the client and the company for developing that product, right? The client who who wants the product, who wants to build the product, and the company who is building the product, there will be a contract that would be signed between the client and the company initially for developing that application. So an acceptance criteria would be defined before signing the contract. So there would be acceptance criteria mentioned in the contract that is performed against those acceptance criteria is called the contractual acceptance testing. So any acceptance criteria that is mentioned in the contract, when you do a testing against those acceptance criteria, that is a contract acceptance testing. So this could be done by individual users, independent testers, or sometimes depending upon the criteria, other field of testers should also be doing this. So for example, if it is written in the contract that this particular application should be developed in iOS as well as Android platforms, we have to make sure that the application is available, stable, and ready in both the platforms. So any acceptance criteria mentioned in the contract that is being tested, we call it as a contractual acceptance testing. And next is regulatory acceptance testing. So based on the domain in which the applications which is being developed is there. For example, it could be health domain or a telecommunication or a traffic. For example, if you are developing an application for a hospital, or any other health domain application, we have to make sure that it abide by the government's regulation on that particular domain. If there is any such regulatory boards, we have to make sure that this application abides by all the rules of that particular board. For example, for any applications which has a financial transaction happening in it, we have to make sure that there is a proper fraud check that is being done. So any regulatory testing that is to be done based on the domain in which the application is being developed. The regulations could be government or legal or medical or safety. We have to do a testing and make sure that this particular application abide by those regulatory boards. That is a regulatory acceptance testing. So again, this will also be done by the independent testers or by the regulatory agencies. And finally, we have the alpha and beta testing. So alpha and beta testing. So the difference is that the both alpha and beta testing will be done by the potential or existing customers. So in alpha testing, the potential or existing customers will be doing it in the developer's environment. So that is, the environment is a difference. The alpha testing will be done by the existing potential customers in the developer's environment, whereas beta testing will be done by existing users or customers in the external site without the developer's environment. So why we are doing this alpha and beta testing? Beta testing we are doing to get the feedback from the actual user. So if you look into the Play Store or App Store, we can see there are a lot of application which is available in the beta for the beta version. Why? Because they want to get a feedback from the mass market, how the actual users are responding to this application. So they have provided the beta version. So alpha and beta testing both are done by potential or existing customers. Alpha testing would be done by the existing customers in the dev environment, whereas beta testing would be done by the existing users or customers in their external site. So they will download the beta version of their application and use it in their house or wherever they are. So it is done to acquire the feedback from the mass market. So it has happened that there are many applications which is available in the beta to get the feedback from the actual users who will be using the application. So these are the different forms of acceptance testing. So with that, we have come to an end to the test levels. So next is test types. So there are few characteristics of the test level. So the first is test specific objective. So these are the different characteristics of each of the test levels. Like specific objective, the objective of component testing will not be the objective of acceptance testing. So in component testing, we are checking the code, whereas in acceptance testing, we are checking the fitness of the application. And the test basis is a source of information, or on what basis we are preparing the test cases. So reference to derived test cases. So whatever we reference to derive the test cases, that is a test basis. So the test basis for component testing would not be the test basis for acceptance testing. So for test basis, for component testing would be some piece of code based on which we will be validating. Whereas for acceptance testing, we will be looking into the requirements document to verify the acceptance test cases. So test bases will be different for each of the different test levels. Then the test object. So whatever is being tested. So the test object for component testing is some piece of code. The test object for the acceptance or system testing is a whole application. So each level has its own attributes or characteristics for each and every point. So the next one is typical defects and failures. So what would be the typical defect in a component testing? Some errors or issues in the code, that would be a typical defect in a component testing. What would be a typical defect in a component integration testing? Some communication issue between two different components. What would be a typical defect or failure in a acceptance testing? It will be some like issues, requirement issues, or bugs or defects. So each level is characterized by its own defects and failures. And finally, specific approaches and responsibilities. So for each level, we will have to maintain different approaches and responsibilities. For example, in acceptance testing, who will be doing the testing? It will be the client side or the customer. So whereas in unit testing, it can't be done by the customers. It should be done by the developers who are writing the test unit code. So each of the different test levels has its own different attributes which that is needs to be distinguished between each of them. So that is very important. So these are the different characteristics. So next is the test types. So this we will continue tomorrow. So we'll just go through all the topics which we have discussed today. The first one is testing in the context of a software development lifecycle, which is how testing happens in different SDLC models. We are looking into each and every SDLC model from a testing perspective. And next is impact of SDLC on testing. So how testing is being impacted by different activities of SDLC for each traditional as well as the agile models. And then we have the different testing practices irrespective of the SDLC that is being followed in our project. There are few good testing practices that needs to be followed to get a better quality product. And then we have testing as a driver for software development. So there are few approaches where we are trying to write the test before actually writing the code, or testing is actually driving the whole development process. So we have the test driven development, acceptance test driven development, and behavior driven development. And next we have DevOps and testing, how testing is embedded in DevOps, and how different activities are automated using DevOps, and what actually happens in DevOps. And along with that, benefits and risks of DevOps. And finally, shift left approach, where we are trying to actually shift the testing from right to left, to get an early feedback and to identify issue at the earlier phases of the development. So how we can implement shift left approach, the different ways by which we can actually implement shift left approach. And next is retrospective and process improvement, how retrospective can actually improve the whole process that has happened in a particular piece of work, that could be an iteration or a release. And the benefits associated with the retrospective. And then we have the test levels, different levels of testing, component integration, system integration, and finally acceptance testing and its different forms, and the different attributes or different characteristics of the each and every test levels. So these are the different topics which we have covered today, and tomorrow we will start with the test types, and then there are few topics in this module, and then we will complete the module 6 as well, which is a short module. Okay. Is there any questions in this module till what we have covered? You can ask now. If there are no doubts or questions, you're free to leave. Thank you. If there are any questions, you can put it on the chat also.